Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is section 7.3, conditional probability, the product rule. I'll talk in this lecture, in this video, about conditional probability. We studied probability and sometimes there is some information given, and this information given reduces the sample space of the probability experiment. For example, when we roll a die, the sample space consists of numbers from 1 to 6. If I ask you roll a die, what is the probability that 5 occurs? You will say 1 over 6. But if I ask you what is the probability that 5 occurs, given that an odd number is rolled? So now I have this information that an odd number is rolled. So if odd number is rolled, we write it like this, okay? The probability that 5 occurs or rolled, given that odd number rolled. So if the information is the odd number is rolled, so the sample space is not going to be from 1 to 6. The sample space would be 1, 3, and 5. And now I have to find the probability that 5 is rolled, but not using this sample space, using the odd numbers sample space. So 1 is one number out of 3. So the probability would be 1 over 3. So 3 is the number of odd numbers rolled. 1 is the number of 5 and odd numbers rolled. So you can say that the probability of 5 given odd numbers is the number of elements in E intersection S1 over the number of elements in S1. So this is what we mean by conditional probability. This is called a conditional probability because there is a condition. There is a given information, which is the number rolled is an odd number. So in Venn diagram, S is the sample space. But when you say given B, probability of A given B, so the sample space would be only B, not S. So there is a new sample space we are talking about, which is B, because B is the given information. And then we need to find the probability of A given B. So we look to this part, which is A intersection B, this part, and we divide the number of elements in A intersection B over the number of elements in B. So this is the definition of the conditional probability. Notice that we are finding the probability of A. Okay, so there is a probability of A and there is a probability of A given B. Probability of A is called the unconditional probability of A. So then there is no condition here. To find the probability of A, usually you use the sample space. You divide by the number of elements in the sample space. But for the conditional probability of A, when B is given as a condition, you divide by the number of elements in B, not in the sample space S. Suppose the following table summarizes the opinions of various groups in a survey on the issue of increased enforcement of immigration laws. What is the probability? That's the question now. What's the probability that a person selected at random from this group of people is non-white? How many people are there? If you look to the table, these are whites, non-whites, favor, this is the opinion, oppose, and the total. These are the totals. So here 1,000, this is the total number of people in this survey. Okay. So we will do what? We will select a person. A person. We will select a person at random. And the question, what is the probability that this person is non-white? So how to find the probability that a person is non-white? Okay, you can call it E or whatever, non-whites. Well, number of elements in the sample space, number of people in the sample space, and number of non-whites. How many non-whites are there? We have Republicans 50, Democrats 200, so we have 250. So this is the probability that a person selected is non-whites. This is A. B is non-white. What's the probability that this person is non-white and favors increased enforcement of immigration laws? Favor, this is favor, and non-white. So, and so he's asking about probability of non-white, and you write it as an intersection, or you just say and favor. So number of elements in the intersection over the number of elements in the sample space. How many are there in the intersection? Well, we have 25 Republicans and 10 Democrats. Both are non-whites and in favor. So 25 plus 10, 35. So this is the probability that the person is a non-white and in favor. Okay. Part C favors increased enforcement of immigration laws given that. If there is a given that, then it's a conditional probability. So what is the probability that this person in favors increased? So probability of favors. Given that, what is the condition? The person is non-white. So given that the person is non-white. So now how to define this probability? Now we do not divide by 1000. We divide by the number of non-whites. And the number of non-whites is 250, as you have seen, 50 plus 200. And now we need how many are in favor among these 25 people, and they are 25 plus 10, so we have 35. Okay, so that's the difference between the usual probability and the conditional probability. So this is the answer. Now, if we divide the numerator and the denominator by number of elements in S in the sample space, we will get probability of A intersection B over probability of B. So we can also say that probability of A given B is probability of A intersection B over probability of B. And you have two ways to find probability of A given B. Either you use the number of elements of A intersection B over the number of elements of B, if it is available, or you find the probabilities. Okay, both will give you the conditional probability. A red die and a green die are rolled. So rolling two dice. What is the number of elements in the sample space when you roll two dice? It is 36. Okay, we studied this in 7.1. What is the probability that the sum rolled when we add the two dice? Okay, we could have a sum of 2 when we have 1, 1, up to 12 when we have 6, 6. What is the probability that the sum rolled on the dice is 6? So he's asking that the probability that sum is 6, given that the sum is less than 7. So sum is less than 7. He's asking about this probability. Well, the answer would be If I want to use number of elements, it would be the number of elements in sum less than 7. So I have to find out how many of these 36 have sum less than 7. So sum less than 7 would be, let us write this set. I started by 1, 1, 1, and everything with 1. And now 2, 2, 2, 1 is there. So just 2, 3, 3, 2, 3, 3, less than 7. There is also 4, 1, 4, 1 and 1, 4. This is 1, 4. 4, 1 and 1, 4 are already. So 5, 1, 1, 5. And what else? What about 4, 2? Yeah, because less than 7. 4, 2, and 2, 4. So these are all the outcomes with sum less than 7. If you count them 6, 8, 10, 11, 15, we have 15 outcomes with sum less than 7. Now we need sum is 6 among these. So we have 3, 3, these two, and these two. These 5, the sum is 6. So how many? 5. So the probability is 5 over 15. Okay. We used number of elements. You can use also probability. So you can find the probability of sum is 6 intersection sum is less than 7, which is 5 over 36 over 15 over 36, and you will get the same answer. Suppose that one ball is drawn from a bag containing 4 red balls. Up to now, we are selecting one ball, one card. We have 4 red balls from 1 to 4 and 3 white balls from 5 to 7. The question, what is the probability that the ball is white given that it is an even number? Also, I can use the number of elements. How many even numbers are there? 2, 4, and 6, 3 even numbers. How many white balls among these 3? Well, the white balls 5, 6, 7. The only even number is 6. So there is one even and white ball. So the probability is 1 over 3. A card is drawn from a deck of 52 playing cards. Okay, again, this is one card. Given that it is a red card, okay, so we have this information. What is the probability that it's a heart? So he's asking about probability of heart given that it's red. So look to the red card. How many red cards do we have? Well, we have half of the cards are red and half are black. So we have 26 red cards. How many of these 26 are hearts? Well, the heart, all of it is red. All of the cards of the heart are red. How many hearts are there? 13. So probability of heart given red would be 13 over 26. Probability that it's a king given red. How many reds? 26. How many kings in the red? We have two suits, two red suits. So there are two kings only in the red cards. So 2 over 26. A die has been loaded. Loaded means it's not fair. So that the probability of rolling any even number is 2 over 9. When we roll a die, we have probability 1, 2, 3, 4 up to 6. So probability of 2 plus, equals equals probability of 4 equals probability of 6 equals 2 over 9. And the probability of rolling any odd number, so probability of 1 plus equals probability of 3 equals probability of 5 equals 1 over 9. Now, what is the probability of rolling a 6? What is the probability of rolling a 6? Okay, given that an even number is rolled, even. So let us say that it's the probability of 6 intersection even over probability of even. So what is the probability of getting an even number? Well, these are the set of even numbers 2, 4, and 6. And the probability of even would be 2 over 9 plus 2 over 9 plus 2 over 9. So it's 6 over 9. And 6 is one of them, so it is 2 over 9. So the probability would be 2 over 6. If you say that the number of even elements are 3 and 6 is one of them, you get also 1 over 3. Now, rolling, but this is the correct method in this case because it is not equally likely. The experiment is not equally likely anymore. What is the probability of rolling a 3 given that a number divisible by 3 is rolled? What is the number divisible by 3? We have 3 or 6. What is the probability of D? So this is D, okay, divisible. Probability of 3 intersection D, so it's probability of 3. Probability of 3 is 1 over 9 because 3 is an odd number. Over probability of D. What is probability of D? Probability of 3 is 1 over 9. Probability of 6 is 2 over 9. So probability of D is 3 over 9. 2 plus 1. So the probability is 1 over 3. So if you say here that the numbers of elements divisible by 3 is 2 and 3 is one of them and the probability is 1 of 2, your answer is not correct. So when the experiment is not equally likely, we have to use this formula, the probability, that the probability of A given B is probability of the intersection over probability of B. Number of elements will not work here, okay? So this is a very important exercise. Keep it in mind. A bag contains 9 red balls, numbered from 1 to 9, and 6 white balls, numbered from 10 to 15. One ball is drawn from the bag. What is the probability that the ball is red, given that the ball is even? Well, here, equally likely, I have 15 balls. Each ball can be selected. How many even balls are there? I have 2, 4, 6, 8, 10, 12, 14. So I have 7 even balls. This is the number of even balls. How many red balls? 9 red balls. How many of them are even? 2, 4, 6, and 8. 4. So 4 are red and even, 7 are even, so the probability is 4 over 7. A bag contains 4 red balls, 6 white balls. 2 balls are drawn without replacement. What is the probability that the second ball is white given that the first ball is red? So we need to find the probability that the second ball is white. Let me call white 2, the second is white, given that the first is red. So let me call it red 1, the first is red. Now I can find this probability using a tree diagram. I'll make a tree diagram. And we will learn about tree diagrams more in the next video. So the first ball, let us draw the first ball. What are the possibilities for the first ball? It could be white or red. And now the second ball, if the first ball is white, let me call this W1R1. The second ball would be white or red. White or red. This is the second ball. Now what is the question? Find probability of W2, this one, given that the first ball is red. Okay, what is the probability that the first ball is white? How many white balls? 6. What is the probability that the first ball is red? How many white balls? 4. Red balls, sorry. So probability that the first is red, 4 over 10. Probability that the first is white, 6 over 10. Notice that we are selecting 2 balls. Now, is it with replacement or without replacement? Without replacement. What is the meaning of without replacement? The ball we selected in the first draw, we will not put it back with the balls. So now we selected a ball and the number of balls is not 10. The number of balls is 9. So what is the probability that we select now another white ball given that the first is white? Well, I have 9 balls and the number of white balls is not 6 anymore, it is 5 because we selected one white. So the probability of selecting white ball in the second row, given that the probability, given that we selected white ball in the first draw is 5 over 9. So always the probabilities here are conditional probabilities. So probability of R2 given W1 would be how many red balls are there? 4 over 9. Probability of W2 given R1, well, we selected red and we need white. We have 6 white balls over 9. Red 2 given red 1, well, we have 3 red balls left because we selected 1 over 9. So probability of W2 given R1 is 6 over 9. And you can think of it like this. And we have 10 balls and we selected red in the first draw. So now the number of balls is 9. We have 9 balls. Since we selected red, so 3 are red and 6 are white. So the probability of selecting white now is 6 over 9, and that's the probability. What is the probability that the second ball is red given that the first is white? So also you can think like this if you don't want to use the tree diagram. The first ball selected is white, so now we still have 9 balls. And how many whites were there? We had 6 white balls. Now we have only 5 whites left and 4 red. So what is the probability that the second ball is red? So 4 over 9. So this is the probability that the second ball is red, given that the first one is white. And you will find it also from the tree diagram R2, given W1 is 4 over 9. Answer part A, if the first ball is replaced before the second is drawn. Replaced means we put the ball back. So part A now, what is the probability that the second is white, given that the first is red? Well, after the first draw, we put the ball back. So the number of balls is 10. So now we will divide by 10. And the number of white is 6 and the number of red is 4. So probability of white now is 6 over 10. Okay, because we replaced the ball, we put it back. So we always have 6 white balls out of 10. But here we selected a ball, red, and we did not put it back. So we had 9 balls, 6 of them are white. But now we have the 10 balls, 6 of them are white. A fair coin is tossed 3 times. When we toss a coin 3 times, we know that the sample space is HHH up to TTT. We studied this in the previous section. Find the probability throwing 3 heads? 3 heads means HHH, given that the first toss is a head. So head first. Well, let us find the number of elements. If head first, okay, head first, what do we have here? We have HHH, HHT, HTH, and HTT. 4 of these 8 head first. So we divide by 4 because number of elements are 4. Outcomes, and head is one of them. So the answer would be 1 over 4. Throwing 3 heads, so probability of head, or 3 heads, given that the first tosses result in head. First 2, so H first 2. So first 2 would be head, and head, T. We will have only 2 of these results in first 2 heads. So now the probability would be 1 over 2. Suppose the table summarizes the opinions of various groups on the issue of oil drilling in national parks. Use this table to calculate the empirical probabilities in these problems. Given that a randomly selected individual is non-white, find the probability that he or she opposes oil drilling in national parks. So what is the probability of opposing, given that non-white? Number of elements, number of non-whites, we have 250. Number of oppose, we have 25 plus 190. So these are the number of oppose inside among the non-whites. So we have 215 over 250. You can leave it like this, or you can write it in simplest form. It is always Both are correct. Both are accepted. Given that a randomly selected individual is democrats, find the probability that he or she opposes. So we need opposes among Democrats. Democrats. How many Democrats are there? We have 350 here, and we have 200 here. Democrats, Democrats. So we have 550 if you add. How many are opposing among these Democrats? We have 250 plus 190. So it is 440. Given that a randomly selected individual is in favor, find the probability that he or she is a Republican. So the number of peoples in favor. The total of in favor is 435. How many of them are Republican? We have 325. So 325. So this is the definition of given that. Also, you can just write it like this or divide and write the answer in simplest form. Both are accepted. Find the probability that a person who favors oil drilling in national parks is non-white. Find the probability that a person who favors oil drilling is non-white. So we know that this person in favors of we know that he is in favor. Okay, and find the probability that he is non-white. Find the probability that a person who favors oil drilling is non-white. So is it the probability who favors so conditional. Find the probability that who favors. We know that he favors. We know that he favors oil drilling. If he, it is another way of asking about given that. So given that he is in favor, what is the probability that he is non-white? Pay attention to this kind of questions. So favor in total 435. And how many of them are non-white? 35. So this is another way of asking about given that. Find the probability that an individual is a white Republican opposed to oil drilling in national parks. So he is white Republican. These are the white Republican. Could be favor, could be oppose. So these are white Republican. So find the probability that an individual is a white Republican opposed to drilling in national parks. And he is opposed. Okay. So here, you know, there is a difference between the way of the question asks. Find the probability that an individual is a white Republican, not who favors oil drilling. So here, this is a given information, but here, no, he is asking about intersection. Find the probability that an individual is and, okay, is a white Republican and opposed to oil drilling. So we have 100 people opposed and Republican among the 1,000. So the probability here, he is asking about white, Republican, and opposed. It is 100 over 1,000. I stop here and I continue in another video.